Let's talk about the Planck's quantum theory, which was given by Max Planck in 1900 to explain the emission and absorption of radiation. As the radiations possess the energy, so he said that the energy is neither emitted nor absorbed continuously, but in the discontinuous manners in the form of wave packets. These wave packets have discrete energy and these are termed as quanta. In the case of light, these quanta are known as the photons. The blocks you see here have the waves, which are the photons of light or which are the quanta. The singular of quanta is a quantum. As you see, the photons or quanta are the wave packets possessing waves. So they must have the properties of waves. These waves possess the energy and their energy is related with their frequency. Frequency is the number of waves per second. Greater is the frequency of a photon, greater is its energy. This relation is summarized in this equation, which says that energy is equal to h mu, where h is the Planck's constant, that is equal to 6.626 cross 10 to the power minus 34 joule second, and mu is the frequency of wave. As the photons are wave packets, so they must have the wavelength. And the wavelength is a distance between two crusts or troughs. This wavelength is inversely related with the frequency. Greater is the frequency of the wave, lower will be the wavelength. When the maximum number of waves are passing through the point, the distance between the two crust and trough will definitely be small. And you can say that increasing the frequency decreases the wavelength. This relation is summarized in this equation, which is mu equals to c by lambda. This c is the speed of light. By putting the value of mu in this red colored equation, you find this E is equal to hc by lambda. The photons or quanta also possess the wave numbers, which are the number of waves per unit length. And these are inversely related with lambda. So mu bar equals to 1 by lambda. By putting the value of lambda, you find out that E is equal to hc mu bar. Now we can conclude that energy is in the form of wave packets which possess frequency, wavelength, and wave number. And the energy is neither emitted nor absorbed continuously, but in the discontinuous manners in the form of wave packets or in the form of quanta or photon. Using this concept of discontinuous emittance and absorbance of energy, Bohr worked out on the structure of atom and he tried to figure out the position of electron around the nucleus of atom.